The focus of this presentation is aimed to critically analyse and evaluate the following study, titled The Effects of Problem-Solving Strategies on Students' Achievement, Attitude and Motivation. The layout of this presentation will be presented from a brief description on the importance of problem solving, introduction to the study, briefly describing the assessment strategy, which includes the participants, measuring instruments and results, and the study's strengths, weaknesses and implications. Problem solving refers to the effort needed to achieve a goal or to find a solution when there is no automatic solution available. And one of the fundamental achievements of education is to enable students to use their own knowledge in problem solving. And as stated within the study, physics students do not solve problems at the wanted level of proficiency. Therefore, the focus of this study is to discover how students can become more expert-like in their approach to physics problem solving. The assessment strategy is a relatively straightforward assessment aimed to detect differences in learning outcomes organised between two periods of time before the condition and time after the condition. The design of the study was implemented within a two groups control group design, in which a pre and post test design with a control group was used. Participants chosen for this study were two classes of 10th graders from Turkey. The students were randomly assigned to one of two groups, either the experimental group or the control group, and were given a pre-test, treatment, and a post-test. The experimental group consisted of 25 students, 12 female, 13 male, and the control group consisted of 21 students, 8 female, and 13 male. The measuring instruments of the research collected data through a physics achievement test, problem-solving strategy survey, problem-solving attitude survey, achievement motivation survey, and a problem-solving worksheets. The study was performed during the spring semester in high school, and the courses were taught by the same instructor using the same schedule with different instructional methods, with the experimental group's teaching method as cooperative learning and the control group's teaching methods as traditional teaching. It was noted that when problem-solving achievement of the students increases, the achievement motivation and attitude of the students increased in accordance with statistical data. The results pointed out that teaching of the problem-solving strategies is more effective on cooperative learning than traditional teaching, with the averages of the experimental group's achievement, motivation, strategy level, and attitude were found to be higher than the control group. According to research data, the reason for the experimental group's achievements were effectiveness of the cooperative learning method, explanation in a systematic configuration of problem-solving strategies, and applying these strategies into plan. And the reasons for the failure in the control group's problem-solving strategies were solving problems individually, avoiding information exchange with friends during solving, hesitating to ask unknown topics or questions to teachers or friends, using solution manual of the problems. It was also noted that the teachings of problem-solving strategies within the control group was actually affecting the attitudes of the students towards problem solving. The results showed that the experimental group had a more homogeneous structure, and the control group had a more heterogeneous structure. In conclusion, the two groups control group design ensures all forms of internal validity, and it is a non-intrusive design with an analysis that does not normally require more advanced statistical procedures. The random sampling method, although non-biased, has the tendency to leave with an unrepresentative sample. Problem-solving strategies has been investigated since the 1970s, and it is encouraging to know that within this study, cooperative learning is the more effective learning strategy that best motivates and encourages physics students to perform and participate to a suitable level that is desired. However, further investigations in cooperative learning amongst a larger sample size, another occupational focus, another age group selection will assist in solidifying this finding.